What's up, guys? Today we just kind of have another chem video, and this one actually serves almost as a review for everything that we've talked about in the past. So the first thing that I want to focus on is video 1. We have a 1 times 10 to the negative third molar solution of hydrobromic acid has been prepared. Calculate the H3O plus concentration of this solution, and then is this solution an acid or a base? So the first thing that we need to do to figure out the molarity of our H3O plus concentration is we got to write out a dissociation equation for hydrobromic acid. Now remember, hydrobromic acid is just HBr. And so when we write it out, creating its H3O plus concentration, remember that's the same as the H plus concentration. When we write it out, we have H3O plus as a product plus that Br minus. And so what this tells us is we want to focus right here. Now since there's only one H3O plus, when this is all balanced out and ready to go, that tells us that the number of hydrogen ions produced is just 1. And so we actually have a nifty little equation here that helps us out based on the number of hydrogen ions created. It is the number of hydrogen ions created multiplied by the original molarity will give us the hydrogen ion concentration. And so when we're looking at plugging everything in, we have our number of hydrogen ions, 1, multiplied by the molarity of our solution, 1 times 10 to the negative third. And so that leaves us with our hydrogen ion concentration is 1 times 10 to the negative third. And so that's this first whole problem. Our second one could be a little bit more challenging. I guess we'll find out, right? So we have a 1 times 10 to the negative 13th molar solution of magnesium hydroxide has been prepared for a laboratory experiment. Calculate the OH minus concentration. And then is the substance an acid or a base? Oh, we forgot to answer here. Acid. My bad. So we have magnesium hydroxide, which is MgOH2. And so we do the same thing. We write out the dissociation of this magnesium hydroxide. And so when we write out the dissociation, we have Mg with a plus 2 charge plus 2 OH minuses. And we double check and we see that it's all balanced. And so what this tells us is just like our hydrogen ion concentration from the last one, if we're trying to figure out the hydroxide ion concentration, or that OH minus concentration, we just look at the number of OHs produced. So in this case, we have 2 OHs produced. And so we have the exact same equation, except this time, instead of it being the H plus concentration revolving around the number of H's created, it's the OH concentration which revolves around the number of OHs created. And we still multiply that by the original molarity, 1 times 10 to the negative 13th. Oops. Molarity. And so when we plug everything in, we have the number of hydrogen ion concentration, or the number of hydroxides, 2 OHs, multiplied by our molarity, 1 times 10 to the negative 13th. When we multiply these two, you guys guessed it, we get a hydroxide ion concentration of 2 times 10 to the negative 13th. That's it. Good luck. We'll see you tomorrow.